the auto progress model, where basically we spawn a thread and we read our own completion queues every 500 milliseconds, or whatever the timer's set to, and that's not nearly as performant as a cooperative model from the middleware. And this is one I wanted to talk about, the completion models. So there's kind of an unfortunately underused feature of Libfabric called Selective Completion. And basically, you can ask for 3 different levels of completion. You can say, all right, I want to get my completion for this message send when it's delivered and on the remote side, and maybe not matched yet, but at least it's in remote buffers on the remote node, right? That's the delivery complete model. And that's, probably the most, the deepest semantic, I guess. It's on the remote. It maybe hasn't been processed yet, but we've got it delivered. And then there's transmit complete, which means it's ingressed into the fabric. And there's inject complete, which means it's ingressed into the adapter, but maybe not the fabric yet. So obviously inject complete, you're going to get more latency with that, but we'll get it there when we can. And what's really nice is with selective completion, you can actually run your endpoint in like, say, a lesser completion mode. But let's say you have a message that you really want to be sure it's on the remote, it's like an IPC kind of thing, or like a barrier control message or something. You can actually ask temporarily for full delivery completion on this, and then switch back to the other transmit mode. But I couldn't find any Libfabric providers that ever, or any middlewares that actually try to do that, which is kind of unfortunate. And also OPX requires PHY context too, which is, I think they're either 32 bytes or 64 byte contexts, and all the other providers just ask for the ones that are smaller. So, but what we do with those is we store like our own, they're kind of like our own scratch pad. So we store like, pointers to, things that we care about in these completions. And, MPI kind of gives us that context. It's like, hey, I want this completion to be done. And if there's like a tag, if it's like a receive tag, that'll be in that context. And a whole bunch of other stuff will be too. So that's kind of how it works. These are 5 environment variables for OPX that you would want to look into when you start tuning. The first one is the HFI select. So that's how we deal with if you have a system. Let's say you have a compute node that has 4 different HFIs in it, and you're starting up your rank on, say, processor number 200. Which HFI do you want it to use? OPX will use libnuma, and when it's coming up, and it'll try to score all 4 adapters in the fabric. And it'll say, oh, I'm going to use the one that's the closest to me, that's the least amount of memory latency. But sometimes, I've seen libnuma get it wrong. I've seen libnuma lie. I've seen it change, in the runtime. So it's also highly dependent on bias settings if it's going to work right or not. So what we've added is we've just added the way, there's a map where there's a way that you can tell just via an environment variable, hey, if you're coming up on processor 200, I want you to use the 3rd HFI in the machine. And this way, so all you have to have is one environment variable, and every time that you restart your job, your ranks will at least bind to the same hardware, which, it sounds simple, but it's not. So when you use this, when you use the definite HFI select, it definitely gets you a better repeatability across experiments. There's the delivery completion threshold. So what this has to do with is, so I talked about those replay buffers. We have a bunch of pre-allocated replay buffers, and let's say somebody wants to send just a 16-byte message. What we'll do is, it's so small, we'll just copy the payload out into one of those pre-allocated buffers, and then we'll just replay it. We'll just run it through our replay logic right there. And that way we can hand the buffer back to MPI. We can say, okay, here's your send buffer. I got your stuff. Like, take it back and do something else. And seen a lot of times on like ping pong type of benchmarks and latency benchmarks, where just handing them that buffer back as fast as you can gets you like way better latency. And I think it's kind of just an artifact of the benchmark, but it's still, it's fun to see it in action, and it actually does something. And the reason that we have it is because we'll only go up to, so, you can send an arbitrarily huge message in MPI, right? Like say you're sending a 4 gigabyte message. Well, we're not going to sit there and copy all the pages of that 4, bounce buffer them and then send them. We're going to tell MPI, okay, so hold this message, don't take the data back, because we might have to replay parts of it, they might get dropped. So you have to keep the original message intact until the completion's done. So you pretty much have no choice but to do full delivery completion on that. So anyway, this delivery completion threshold kind of tunes the threshold when we'll switch to hey, we're not going to give MPI the buffer back. So it's usually like 16 or 32K, and that has impacts on performance. There's also the RDMA, expected receive. It's not on by default right now, but if you set this environment variable to enable, it'll turn it on, and we'll be doing full RDMA on the remote side, which I think starts at either 32 or 64K message lengths. And you definitely, that's where you start seeing in the OmniPath, you'll start seeing the hardware offload features, you know, the SDMA features start to kick in, and you start getting a lot better overlap when we get into that range. Then there's two reliability tunings right there. Basically, the thing to think about with those is the lower those numbers are set, the more reliability OPX is going to do. So if you start getting like bigger jobs like 10,000 ranks or more, you might want to set these to higher values, because it's going to generate less overhead traffic on the fabric, and there's going to be more room for user traffic, which is what you actually want to do. So setting these, it'd be nice if OPX just was able to tune these at runtime and just not make the user have to do it, but we're just not there yet. It's runtime tuning on that requires a lot of testing and a lot of every app kind of has a different profile, really is what it amounts to. So right now you kind of have to discover those on your own and set these. These can actually make a really big difference for apps. Then I have, there's a couple of, the driver has a lot of module parameters, a lot that you're not going to care about, but there's two that you might. One is the receive header count, which is the depth of the eager rings that OPX creates. By default, that's 2K, and 8K is the one that I would recommend you use. And all that's going to do is increase your memory footprint a bit. We're not going to allocate any more replay buffers. We're basically just going to map more memory into the hardware. And the way that the eager works is those are pre-allocated bounce buffers for the hardware to have a place to, it gets fabric egress, right? A packet comes off the fabric. We only have so much buffer in the adapter, right? We got to get it into host memory like right away. That's what the eager ring is for. So that's the main way to receive. The other way to receive is the RDMA way, which requires us to have pages pinned in the SDMA engines programmed. But the way that works is when the packet does come in on the fabric, the RX engine will actually DMA those directly into the user's memory buffer without any interrupts or anything like that. So that's it's higher latency to set that up. But that's actually, that's where, like, if you watch OPX on a bandwidth graph, if you see it like snap into like line rate like really fast, it's because we're using that hardware offload. That's easy to hit line rate when you're using that. And the other one is the number of user contexts. So that basically what we have to do is when the driver's coming up, it has to look at all the HFIs in the machine and take a guess at like how many ranks are they going to try to throw at us? Like how many are they going to run 96 threads on this adapter? Or are they going to only run 32 ranks or there's even more, like 160 is our max. And so if you're going to run less than the processor that you have in the machine, if you set this number of contexts to less, it's actually going to make things faster, because we're going to allocate the resources and we're going to know, hey, even though they might run 96, we only have to deal with 64 because that's what they told us. And so it's going to be more performant. There's going to be more credits, and there's going to be bigger buffers that we set up for that. So those are kind of two quick ways to optimize. Here's, okay, so this is a little bit about, I'm sorry this is so small, but this is a little kind of what the traces will look like. Users, obviously, developers like myself need these, but users can make a lot of use of these too. And these are some of the traces on the Init path. So this isn't the crit path. So OPX, we do a lot more logging, and we do a lot more like user-friendly stuff on the Init path, because, it's a luxury in HPC that, you don't have to worry so much about performance on the Init path. So basically what you can see here is like, when the rank comes, this is per rank, right? So that's the Libfabric trace format on the left there. You can see like the PID, and if you had prepend rank, that would print out there. You can see the PID, the adapter, and then the function name, whatever's cutting the log. And so this is where you can tell, like, hey, rank number, the rank that's running on core number 200 is using HFI number 3. That's the top message that I have highlighted there. And the other ones is, like I was talking about, the number of contexts. If you're going to use, if you're going to undersubscribe, basically, you'll see it happen in the number of contexts right there. So that's kind of a way to check your feedback that your tuning is working right there. And I don't have time to get into the other stuff. So this is another thing that I think users can make use of that I've actually, that's helped me a lot is the debug counters that we have in OPX. So this unfortunately requires a recompile because these, we can't be having all these counters at runtime when users don't care about them, because it actually slows us down quite a bit. But basically, what I've done, the main thing to do with this is if you have a hang in your HPC job, if you're, there's 200 ranks and it's just sitting there waiting forever, when you set this up and you just compile with like, say, the reliability counters, you're going to see like probably like 198 ranks where the counters never change, and there's going to be like 2 where they're updating. And so that starts to narrow you in on like, all right, where are you hung? What's the reason that you're hung? Why, why is it doing this? And you start narrowing in on the node and then the rank, and then eventually you can, if it is a problem in user space, you can, this will help you at least track it down. It's not going to find it for you, but you can at least home in on it with these counters. So I've done that many times, and we did decide to, we weren't going to upstream it, but we did upstream it and made it available to users for extended debug. So I think it's kind of a nice feature. Yeah, so here's a last slide here. So yeah, kind of the current status, I tried MVAPH2 with our latest Libfabric builds last week, and it was a great out-of-the-box experience. It worked right away, and every app that I ran at it came up and ran in a performant way. So really easy to use. We have Libfabric 119 is coming out within the next couple of weeks. We haven't upstreamed our stuff, but we have about quite a few lines of code coming up for that release of Libfabric. And it's, there should be a pretty good bump in OPX features that you'll see in that. We also have, the large message, I talked about the RDMA, TID, we'll call it TID, the overlap, SDMA offload, that's going to be upstreamed. We also have the first round of GPU support that we're upstreaming. So that's via the host memory interface, what OFI calls HMEM. And that's pretty much host memory to GPU, a formalized interface to kind of manage that. So OPX has support for that right now. The best thing that I would do, I guess, would be to clone Libfabric and just check out the main branch and compile it and run. I mean, usually the main branch is pretty stable, and I've done that several times and had good results. So that's pretty much all I had. I don't know if I have a lot of time left here. We have some time. Did anybody have any questions or want any extra insight or anything?
Yeah, we can have in person as well as over Zoom. And those who are on the online, please post your questions to the QA box, and then we'll be happy to ask the questions to the speaker.
Okay.
Yeah, so sorry, those who are on the online, if you have any questions, please post those to the Q&A, and then the speakers will be very happy to answer those things. Might be here, we have one.
Yeah, thanks for the great talk. I was wondering, for the debug counters, are there standalone APIs to query them, or they're not supported right now?
No, the standalone API is a static function that you can call in GDB. So not really. The way that they work by default is we'll print them all out, and you can enable them. The sharp define that I had in this code will enable all of them. You can enable the more granular ones, and the best thing to do is just search for that sharp define in the code, and then you'll see it's really easy. You just define one of them, and you'll get those. And the default behavior is whenever the job finishes, all the ranks will print out whatever counters you have enabled. You have another question? We're getting the mic over there.
Okay. I had a couple of questions. So, do you have any sort of timers to profile how long a message took over the network or something like that, or is it just the counters you talked about?
Yeah, not so much timers in OPX. We don't really have the luxury of doing a lot of timers and things because it's HPC environment. So the only timers that I've seen are ones that are done at higher level, like by, you know,
The
like
MPI level.
MPI
Okay.
level, yeah.
You also talked about the onload versus offload thing, right? So do you also, are you planning to support external devices, like for instance, SmartNICs or something, so that they can progress communication on behalf of the CPU or something like that, or do you have that in your plan?
I don't think it's in the plan yet, but it sounds like a really good idea. If there was, you know, if there's any user desire for something like that, or even investigation into something like that, ask me or ask Brian Smith, who's my boss's boss, and he, you know, we can make sure the right people know about it.
Okay, thank you.
Thank you. Looks like we have one more.
Sorry if this is a newbie open OmniPath question, but for virtual lanes, are there any benefits or pros and cons versus using several virtual lanes versus not? Like if you use many virtual lanes, does that split switch buffers? Or are you better off putting everything into a single lane?
It really depends. I haven't messed with it that much. I actually just wrote the code to make OPX do this. It's you know, we're currently testing it. But as far as I know, the virtual lane configuration, it does on the current OmniPath, you do see like maybe a 30% upload sometimes if you're using static dispersive routing, which I think requires virtual lanes to be configured. And I think it does. And so there's some cases where it does, but mostly it's for like service level guarantees. Like if you're on a fabric, you know, like most, you know, on the bigger fabrics, the bigger computers, to not let like one job intrude on another job, you know, so you don't have a lot of jitter from job to job. That's mostly what they're for. So if it's just you on like a smaller fabric, it's probably not going to get you a lot, but a larger fabric, I think, you know, definitely it gets you a lot better, you know, experience to have the virtual lanes. Sure.
Yeah, so I think you said about the GPU support. So are you considering like both NVIDIA or all kinds of GPUs, or how, what is your roadmap, how you want to roll those out, NVIDIA, AMD, Intel?
Yeah, the one that we've been testing on right now the most is the NVIDIA GPUs, and that's you know, the most performant and the best working right now. The one that we're going to start next is probably the Intel ZE GPUs. Those will be next in line.
Any other questions from the group? Okay, so if not, let's give a big thanks to